So in this class, we are going to discuss about slant triangular edge. Okay, slant triangular edges. Suppose say problems based on slant triangular edges if it comes in the examination. So what you should do? In the previous class, we discussed about slant triangular face. So in this one, we will discuss about slant triangular edges. So I am taking one problem on pentagons, which is resting on slant triangular edges. Okay, slant edges. Okay, he will just say slant edges, not triangular, slant edges. Okay. So before we start this, you must remember that slant edges means that it will always rest on your corner. Okay. This particular problem number is 36. Okay. You can go through that. Slant edges means you have to draw it in corner condition. Now he says a pentagonal lamina of 25 mm sides rests on one of its slant edges. So 25 mm side is this each side length of the pentagon. So draw a pentagon. You know how to draw a pentagon. Okay. Just draw a pentagon. Select the whole thing. Change it to 0.5. Then make sure that it is right side. You should get the corner, right? So here you should get the corner. This particular should be the corner. So if you make edge here, you will get a corner in this side. So this particular point, how to find out the axis here? So here what you should do is first draw on perpendicular bisector, straight line here. Okay. In this case, you need to have the midpoint available here. Just for this particular thing, midpoint is very necessary. Okay. So one line is very easily you can draw the straight line here. When you want to draw the second perpendicular bisector, you have to draw it on the midpoint of the opposite edge. From this corner, this is the opposite edge, midpoint of this one. Here you should draw. So after you get this particular point here, this axis point, the intersection point when you get here. So what you should do is just zoom in. Okay. You will get the intersection point. Draw this line straight. This is your projection line. Now after this, you can remove this part also. Okay. Now just join from every corner to the point, so that it becomes your pyramid. All these points will be 0.5 mm, 0.5 mm thick, because it is in the top view, so it will look like this. So this is your axis line projection. So again, project from all the points. Project it from here, and you know these 2 points will always lie on the same line, so it will be here. And we know that you must always project the axis line first. So in pyramids, this axis line is given as 50 mm. Just enter 50 as axis line. Okay. After you draw the axis line only, then only you will just join these lines here. So join this line totally. Okay. Then you join this. And also you have to join from here, because this is also one of the edges. So when you are seeing this from in the front view like this, if you're seeing this from here, this edge, and this edge will be visible. So these three edges are visible edges. Okay. And the others rest will be overlapping on each other side. So select the whole thing, change this to 0.5 mm. Axis must be 0.35. Okay. So whenever he says anything, any problem, if it is square pyramid, pentagonal pyramid, or hexagonal pyramid, if he's saying that it is resting on slant edges, it means that it is resting on its corner condition. He will not specifically tell you that it is resting in corner condition. You have to understand the word slant edge means corner, slant triangular face means edge condition. Okay. Slant triangular face means edge condition. Okay. Resting on one of its sides. If it says slant edges, if he says, then it is corner condition. So in this case, after that, this whole procedure is the same. Okay. Just move copy this. Since it is resting on the corner, select this corner, just rotate this. Okay. If you want, you can just what you can do is, when you move copy, make sure that you're placing it nearer here. Okay, why? Because anyway it is going to be rotated, so eventually you will get more amount of space there. So select this side, place it here. Now again project it, like just like the previous problem which we discussed. So we know this is O. I know that O and O1 both will be lying on this one. So here, project this. Okay, let me just project this O1 also. So this is O1. I'll split this O to O1 line, this one. I'll split exactly till here, so that this particular line will be your access line. Change this to 0.35. Okay. Then this particular point is the corner, so just project it till here. This is the point where the corner is available. So this is the point where you are having edges, two edges. So till here. Okay. You can either take 25 and just draw it straight, or you can just use the alignment indicator. Okay. Then one more, other 2 points are there here. You must be very, very careful here because of the lines here. These are very, very close lines. So you may not get a straight line. Just check the angle, 90 degree if you're getting, then it's fine. Okay. From here, you just project a straight line again. Okay. So I've got all the 5 points, out of which one line I've already joined here, this one. I'll just make this 0.5. I'm going to join all the other points. Okay, join all the points. So there is the pentagon which is there here. Okay, just change this to 0.5. Okay, now this is the corner on which it is resting. Okay, but this whole pentagonal face is visible to you guys. Okay, and you can see this edge face. So from this point, you can just take this two line. You can take this join. You can join those two particular edges. So those will be continuous line here. Then even these two edges will be visible to you because those are inclined lines. These two particular edges will be visible to you, but this will be dashed line. Okay, this particular line will be dashed line because that is not visible to you guys. Okay, and here when you are changing this, what happens is, because the axis line is getting overlapped with this dashed line, so you will not be able to see the axis line. So change them to 0.5. Okay, like the whole thing. Now he says appears to be angle again. Okay, so minus 135. Okay, he says it is given as 45. Okay, he has given beta angle. Okay, see, I told you that this particular problem, if he is saying that it is slant triangular, okay, he says that it is resting on slant edges, and here it is given that it is beta angle problem. So when it is beta angle problem, you must remember that you must go for how to do for beta angle problem. Even for slant triangular face or slant triangular edge also, you can get beta angle problem. Not that you will get always appears to be, but you know already how to do beta angle problems. So earlier the axis height was how much? It was 50. Later it got reduced to 46. So what you can do? Just you can go for normal method. Initially take 50. Angle is minus 4. Angle is 45, which is given. Okay. Just draw a locus line. Change this to locus line. Okay. Then again take line command from this and take 46.01. Join this to wherever this mirror line is there. This is your newly formed axis. Okay. But here when you are doing this, okay, it's fine because the axis is already there. So what we'll do is just copy this, select this edge, make sure it is placed on this endpoint, go for rotate, again select the end which you selected earlier, then select somewhere here. Okay, because you know that it is anyway going to be placed on the line here. Okay, so that is the inclination here. So just find out beta angle here, angle between this line and this line. So 50 is the beta angle. Earlier angle which was given is 45. So project this. We know this particular point is O. So this will be straight line here. It will be till here itself. Okay. Again, O1 if you want to project, just project till the intersection. From the intersection, I know O1 is somewhere here. Join this. So from here to here is your axis line. Just draw this. Change this to axis line. Change the thickness of the line to 0.35. Okay. Then rest of the other things. I know that this particular thing is the corner, so it will rest on XY. These two lines are here. Okay. Project this. Another point will also rest on this one line. If you are getting this 90 degree, then well and good here. If you are not getting it, just change the angle to 90, because sometimes the mouse may give you some problem. So other two edges are there. Zoom in if you are not sure about these lines here. Okay, you're not able to find out the endpoints of this. Endpoints are very, very important. You can see that this line is going through this one. Okay, so for that purpose you zoom in. See, it is here. So from here you have to join it on the edge. So this is the point here. Join this line. Another edge is also here. So zoom in just to find this point. Make sure the angle is 90. Okay, so all the 5 points you got it. So join all the 5 points. One. So one point is somewhere here. So you have to zoom in again. This is AB. Another point is on this XY, I guess, because it is from the. Okay, just a second. This line is from the corner, so we are having. Okay, the corner point is. See, you are getting two lines here. One is here, another one is here. So let's start from the corner. Okay, so from the corner, this is another point. Third point, fourth point. 1, 2, 3, 4. Fifth point is also here somewhere. So this is your fifth point here. Just join back. So select all the lines. Must be very, very careful while joining the lines. Okay, change it to 0.5. Now again, the same method, how to find the dashed line. Select the end point of this. Okay. I think I have made a mistake here. Because this particular projection line had to be, this is the line, okay? So one more, from this point to this point is another line, and again here is your last line. Okay, just change this to 0.5. So this is your pentagon. Now just join this. So this will be continuous. This also will be continuous. This will be continuous. These two lines will be dashed lines when you're joining this here. These two lines will be dashed lines. First select those two lines, change that to dashed lines. Then you select all the other lines and change them to 0.5 mm thick. So that is your answer. Okay. So that is how you're going to do problems based on slant edges. Okay. any problem if he is giving slant edge or slant triangular face, whether it is direct appears to be, or even if it is given as beta angle problem, you must be able to do this. So this will complete your basic prisms and pyramids. So other special cases are there, that is cube is there, you are having problems on cone, you are having problems on tetrahedron. Okay, so those particular things will be very very useful. So those things you must go through. Okay, again I'll be sending you classes videos for those particular special cases. So this particular thing will uh, complete almost 80% of your solids. So problems on tetrahedron, problem on cube, okay, or problem on cone, one problem on each, I'll be sending you a video. So that will complete your solids. So let's finally we'll be completing the solids, and we'll complete isometrics. So I'll see you in the next class.